Hello, I am Anshul from Gofodu.com, and in this video we are going to talk about basics of functions. Function is basically a relation between independent variable and dependent variable. For example, y is equal to x square, where x is independent variable. You can put any value of x, but y's value depends on what value we put for x. So y is dependent variable. Okay, and this equation, this relation is called as function, commonly written as f of x or function of x is equal to x square. Okay, now important thing to keep in mind is that for a function, for one value of x there should be one and only one value of y, then only this relation will qualify as a function. For example, here we can put x as 2, y will be 4, x is 3, y will be 9. Okay, for one x there is only one y, and for one y there can be two values of x. This is allowed. If y is 4, then x can be plus 2 or minus 2. There can be two values of x. This is allowed. But for a given value of x, fx should have a unique value. Then only it will be called a function. For example, y is equal to plus minus root x. This is not a function. If we put x as 2, y will have two values, plus root 2 and minus root 2. Okay. For one value of x, there should be one and only one value of y. Okay. Now function can also be represented like this. We have a set x and a set y, and there are arrows from set x to set y mapping the elements from set x to set y. Here we can say f of 1 is b, f of 2 is c, f of 3 is again c. Okay, there can be two values of x giving same value of y, or for one value of y there can be two value of x. Okay, this is allowed. Now all these values that x can take, this set of values is called domain of function. Okay, and all these values that y gives out, this set is called as range of the function. Okay. For example, we have an unusual function price machine here. This is a machine that prints price on different diaries. Okay, it gives prices of different diaries. Now all these diaries which are entering the machine are called domain of this function, and all these diaries coming out, all these price tags will constitute range of this function. All these values 35, 45, all these values are range of this function. Take another example. This function fx is equal to x square. Okay, for this function all these values from 1, 2, 3, 4, 5 and 6, these will be domain of this function from 1 to 6, and values 2, 4, 9, 16, 25, 36, all these values will be range of function. Now if two functions which have their domains equal, let's say there are two functions f of x and g of x which have their domains equal, domain of f of x is equal to domain of g of x, and their ranges are also equal, range of f of x is equal to range of g of x. Okay, and f of x is equal to g of x for all x that belongs to domain. Okay, if these three are true, then the two functions f and g are said to be equal. That's the condition for equality of two functions. Their domain should be equal, their range should be equal, and for all x within the domain, value of f of x should be equal to g of x. So you can use these 3 points to check if two functions are equal or not. Okay. Moving on to classification of functions. They can be injective or also called as one-to-one, or they can be surjective or onto, or they can be bijective, that is one-to-one onto. One-to-one onto means both injective as well as surjective. So they can be injective, surjective, or both injective and surjective. Now injective function, or also called as one-to-one function, maps each element of x to a distinct element of y. Okay, no two element of x will be mapped to same y. So we can write each x to distinct y. Okay, this is injective function. You see, Assam is mapped to Dispur, Nagaland to Itanagar, Arunachal Pradesh to Kohima. Each element in this set x, is mapped to a distinct element in set y. Okay. Next is surjective or onto. For every y, there is an x. Okay, it need not be distinct, but all y are mapped to x. Not a single y is left unmapped. Like here we had Patna which was left out. It was not mapped to any element in x. But here in surjective function, no y is left unmapped. Okay. So this is surjective function where for every y there is x. Okay. Now here we have 2x. Punjab and Chandigarh both, we have two elements of x which are mapped to same element of y. Both are mapped to Haryana. But that doesn't matter, because for surjective function only focus should be on y side. All the elements in y should be mapped to x, elements in x. Okay. Next is bijective, which is a combination of both injective and surjective. For element of one set, each element of one set is paired with exactly one element of the other set. Okay. And each element of the other set is paired with exactly one element of the first set. Basically, there are no unpaired elements. Okay. In any set. So injective means for every x, there should be one unique y. Surjective means for every y, there is an x, and that x need not be unique for each y. We can have two x's for same y, but for every y, there is an x. And bijective means one from x paired with one element from y, and one element from y paired with one element from x, leaving no unpaired elements. Okay. Other than these three classifications, there are two other type of classifications as well, which can work in any combination of these three. They are into functions and many to one functions. Into function simply means there is at least one element in y that is not mapped to an element in x. Like here, Patna is not mapped to any element in set x. So not only this function is one to one, this function is also into. This function is one to one into. Okay. And many to one, as the name suggests, there will be two elements in x mapping to same element in y. Like here, Punjab and Chandigarh are both mapped to same element in y. Same element Haryana in y. Okay. So this function is onto as well as many to one. This function is many to one onto. Okay. So there is one to one into, there is one to one onto, there is many to one onto. Now my question is, can there be many to one into? Here you go, many to one into. Two elements from x are mapped to same element in y, and there are some elements in y which are left unmapped. So this is many to one into. Okay. Now can there be one to many function? Can there be a function like this? Can there be a one to many function? Well, as we have discussed in the beginning, for each x there should be a unique y. Then only it will be called a function. We cannot obtain two y values by putting a single x value in a function. So this cannot qualify as a function. Now tell what kind of functions are these. This first one is surjective and not injective. All y have a x, and this is also many to one, right? So this is many to one and surjective. This one This is 1 to many, so it cannot be a function. 1x cannot have 2y values, so this is not a function. And this one, this is injective and not surjective. Every x has a unique y and there are elements in y which are left unmapped. C is not an image of any element in x. Okay, so this is 1 to 1 into. Okay, this is 1 to 1 into. And this fourth one is not injective and not surjective. This is non-injective, non-surjective function. Non-surjective because all elements of y are not occupied. D remains unmapped. And non-injective because both 2 and 3 are mapped to C. Every x does not have a unique image in y. Okay, so this is non-injective, non-surjective function. And this last one is a bijective function. Why? Think about it. This is bijective. Injective as well as surjective. Moving on to the last concept of this video. Can we tell from a graph if it represents a function or not? So we have 4 graphs and we have to tell if each of these represent a function or not. Well, draw vertical lines like this. If there are no vertical lines which intersect the graph at more than one point, then the given relation is a function. See, each vertical line is cutting the graph at only one point. There is no vertical line which cuts the graph at more than one point. Okay, so this is a function. And this one is also a function. Okay, all the lines are cutting the graph at one point only. This one is also a function. This third one is not a function. This line is cutting the graph at 2 points. Okay, even this line is cutting the graph at 2 points. So this is not a function. Because for one value of x, if I take this value of x, there are 2 values of y. Okay, this one and this one here. There are 2 values of y for one value of x, which is not allowed as per function's definition. So this is not a function. This graph doesn't represent a function. And this one, this fourth one is also a function. Okay, it need not be a continuous function, but it is a function. Okay, so these 3 are functions, right? 1, 2 and 3, these 3 are functions. Now my question is, out of these 3, which functions are injective? That's right, which functions out of these are injective? That is 1 to 1. Out of these 3, which functions are 1 to 1? Okay, for 1 to 1, for checking if a function is injective or not, draw horizontal lines like this. Draw horizontal lines. If the lines don't intersect at more than once, then the function is injective. But in this case, the line is cutting the graph at more than 1 point. The line is cutting at 3 points. So this is not an injective function. Because for these 3 values of x, for this one, for this value of x and for this value of x, we get same value of y. For 3 different values of x, we have same value of y. So this is not an injective function. This graph number 2 and graph number 4, these 2 are injective functions because the lines, the horizontal lines are not cutting the graph more than once. Okay. This value of y is obtained only by this x and no other. Okay. So only one value of y for one value of x. So this is injective function. So in order to check if a function is 1 to 1 function, if a graph represents 1 to 1 function, we should first check whether or not the graph represents a function in the first place. Okay. So first of all, for a given graph, we will do the vertical line test. The vertical line test should be done first and then the horizontal line test. Okay. First we will check if the graph represents a function or not, and then we will check if that function is 1 to 1 or injective or not. Okay. So in this video, we covered a few introductory concepts of functions. Hope you liked it. Thank you.